parameters, meaning have to kanang kung mag-drawing ka nahanglan yun nga every point or every part sa transmission line naa gyud shunt nimo nga component nga i-drawing. So mura gud na siya og um, area under the curve ba sa sa integral calculus. Di ba katong dx good or dx or dy katong very small na part sa isa ka curve. Di ba gitawag na siya og dx kay very minute na part, no, along x or along y, no, sa curve. So very similar, no, with transmission line because we cannot represent the distributed parameter as very many drawings, no, taghanon nimo kanang shunt capacitances, dili man siya practical, no. So ato siya i-lump, okay? But i-divide na to siya according to its form, no. So there's actually 3 forms for a medium transmission line, okay? So the first one is what we call the nominal pi transmission line. So nganong nominal pi man, di ba? Tan-aw na to ang structure sa pi or ang naong sa pi, di ba? The pi looks like this. Ana. Di ba? The pi symbol looks like this. Okay? Wala na tunggoy-tunggoy. So from that pa lang, tanaw na to ang medium transmission line awa. Eh, no? So mura siya og pi. Okay? So that's why it's called a nominal pi, no, na representation of a medium transmission line. There's also another representation. We call that the nominal t. By that, the nominal t looks like a t. Letter t. Nominal t meaning kanang t nga kanang capital T. Okay? So, in a medium transmission line represented as a nominal pi na transmission line, no? Ang imuhang imuhang shunt capacitance or imuhang shunt component is divided into 2. Okay? Di ba? Y over 2, Y over 2. Okay, and it's end to end, no, sa imuhang series impedance. Whereas ang imuhang nominal T instead of the admittance, no, the shunt admittance being divided, so ang na-divide na is the series impedance. Okay? Please remember that, no? Kung unsay gina-divide, no, sa nominal T and nominal pi. Okay? But later on the next week when siya no ato medium transmission lines. Okay. Oops, naguna. Okay. So we also have long transmission lines. They're more than 150 miles, no? So correct na to balik, miles. Okay. And then the line voltage is very high. Okay, so the usual no na voltage sa long transmission line in practice kay it would go about 230 kilovolts, no? There's also 400, there's also 450. It depends on the origin or the country. So wala na tay gitawag nga very long transmission line. Kung sa voltage naatay extra high voltage, naatay high voltage, naatay very high voltage, to ba? No? Mga na ba mga classes of dinagkuay nga voltage. For long transmission lines, no, tawag na long na siya, wala na very long transmission line, no? Generally it's called a long transmission line. Okay? So for long transmission line, no, ang constants niya we follow, no, the actual jud na uniform distribution of your length, no, or sorry, parameters. Okay? So meaning tanan nimong parameters makitaan sa long transmission line, lowercase r, lowercase l, lowercase c, lowercase g gyud na. Okay? So please remember that, no? They are distributed. Okay? So kung sa integral, no, dx to similar ra kay na siya sa long transmission line because ang imuhang parameter is distributed, so meaning your line is also distributed. The length of the line is distributed. So let's say we have a very long transmission line or a long transmission line, tapos yung length is L, no? We segment it into, let's say, X, no? From this point here to this point here, or this point here to this point here. X na siya. So, ang very gagmay na representation ana niya, we call it delta X or dx, no? Ini, for emphasis, ako lang gina siya, pero actually, gamay jud na, no? Ang imuhang long transmission line, ana, no? Naa na siya, daghan kaayo nga, kung imong drawing ng daghan kaayo nga, saan conductance niya, no? Impedance yan. Distributed all over the length. Okay? So, inani ang long transmission line. Okay? So, any question with the classification of the transmission lines?
And so far, sir.
Okay, so, okay, thank you. So, medyo sayo na masabton, no? Short, medium, long. Okay, there's actually, na ako'y na-miss dere sa medium transmission line. Actually, naay ikatulo, no, nga kanang representation, and this is not a common representation because it oversimplifies, no, the capacitance. But we will tackle that next week. So it's called the end condenser method. So na kay nominal pi, nominal t, and the end condenser method. Okay? End condenser. END. Dili and. Okay? To continue, before tayo mag short transmission lines, no, let us first take note of these very important terms. So these are the metrics for the performance, no, sa atong transmission line. The first metric is what we call the voltage regulation. Okay? So the voltage regulation, no, it is measured by the receiving end, or the voltage regulation is defined by the voltage at the sending end and the receiving end. Okay? So very similar with our machines, no, na classes, apparatus na classes. Ang voltage regulation, pura na siya og either let's say in minus out, all over out sa high, no? Sa mga generators or transformers. So sa high put generated minus terminal voltage all over terminal voltage. Depende na siya, no? But in the context of transmission lines, the percent voltage regulation is the sending end minus the receiving end voltage all over the receiving end voltage, and then times 100. Okay? So, ang atong gina-expect no na voltage regulation yun should be very low. Why do you think should it be very low? Anong kinahanglan low ang voltage regulation?
Because related siya sa losses, sir.
Yes, it's related to the losses. Tanaw lang ka sa imuhang kuan. Magtanaw na ka sa VS ug sa VR. For a transmission line, would you want your VR to be very small? Dili, di ba? You'd want your VR to be as nearly as close as your VS. So, pananglitan, you have a perfect transmission line, walay loss, no? So, in fact, di dyan na siya mahitabo. But let's say VS minus VR. Tapos imong VR kay duol na kaayo sa VS. Let's say approximately VS. So, mao nga VS minus VS all over VS. So, unsa man na siya? 0/1. So, that's a 0% voltage regulation. So, meaning, your line is perfect. No losses. Nana. So, we'd want for a transmission line, any transmission line, either short, medium, or long, we want our voltage regulation to be very small. Okay? Okay. Because, no, in fact, sakto to giingon, it concerns also with losses, and by losses, no? Included man dira ang voltage drop. Okay? So, we'd want, no, a very small voltage drop on the transmission line. Okay? So, sir, asa man na i-voltage drop ang transmission line, sir? Actually, i-voltage drop na siya along the line. Kaya nga naman, because along the line, naamang kay resistive and series, no, na components. Sorry, resistive and inductive na components. Diba? Remember, series impedance composed of R and L. Okay? So, I hope nasabta na sa tanan. So, for voltage regulation, we'd want it to be as small as possible. Now, let's talk about transmission efficiency. So, what is transmission efficiency? Same regular na siya nga definition sa efficiency nga atong naandan sa uban na context, machines, apparatus, no? Even the basic circuits. So, efficiency, no, is mainly defined by its sending end power and its receiving end power. Okay? So, ako na lang gibutang diri lahos, no, ang ato ang formula, though we can really kanang derive for that. Actually, no, na-derive na siya diri pa lang sa formula. Nga naman, remember that power, okay? AC power ha, dili na ta magkuha na ng take note anang DC power nga voltage times current ra. So for AC power, remember that's the voltage times the current times its power factor. Okay? So, sir, kung power factor, sir, ang naandan ra ba sa circuit streak kay usa ra ka power factor ihatag. So, in transmission lines, naatay receiving and sending end power factors. Okay? However, no, sa sending end, since its reference, no, at 0 or no. Let's see. Let me synthesize it a bit. Voltage, current. Okay. Inductor. Yeah. It's not 0 the no. No. The power factor is not part time unless it's given at inyuhang i-assume, no, na power factor for sending end. Take note ha, sending. For sending end is 1. Okay? Pero og naibutang na power factor sa sending end, did you include that in the calculation of the transmission efficiency? Okay? So, voltage regulation, transmission efficiency, those are the most important metrics, no, for our transmission line nga model. Okay? Regardless if it's short, medium, or long, dili gyud na siya mausab. Voltage regulation and transmission efficiency are what are the indicators of the performance of our transmission line. Question: what would we expect for a transmission efficiency? A high value or a low value? Anyone? High or low?
High.
High value.
Hi, sir.
High, correct, di ba? Kay kita mga ii na gud ta, 4th year na gud mo. Kung moingon mo low value nga efficiency, agoy balik ta ana og first year di ay, no? So efficiency is, in the simplest sense, no? Efficiency is the byproduct, no, after feeding an input. So kung imong input power 100 megawatts, dinahan gyud ka nga ang imuhang madawat pod 100 megawatts or duol sa 100 megawatts. No? So, let us all be very careful, no? Makakuha gani mo transmission efficiency, no? Naa po ni cases. Transmission efficiency nila 150%. Agoy, unsa naman na? Lapas na di ay. Meaning, ang imuhang receiving end Imong gilabay ra unta nga power 100 megawatts. Ang imong receiving end kay 150 megawatts. Hala. Sa giunsa man na. Di ba? So let's all be very careful of transmission efficiency. Dili tungod ingon ko dapat high. So pasabot okay ra sa ninyo nga malapas 100. No. No, dili jud siya malapas 100. Okay? Kung malapas sa 100 inyong transmission efficiency, agoy balik ta ana og tan-aw sa imong problem. Okay? For voltage regulation, no? Similarly, dili ta pwede magka-negative na voltage regulation. And why? Why do you think, no? Dili pwede negative voltage regulation. Using the
Sir,
same
kay
analogy.
dako man dapat ang sending kumpara sa receiving kay mag-voltage drop man siya sir sa impedance dapit. So dapat
Correct, no? Yes, yes. Sakto, no? Thank you, John Paul. As Villaban said, no? Dapat ang imuhang receiving end, no? Mas gamay siya sa imong sending end. However, if you still remember problem set number 3, no? Ferranti effect. Unsa to'y definition sa Ferranti effect? Anyone? Or in your own words, unsa to ang Ferranti effect? So Ferranti effect, di ba? Unsa to? Ang receiving na noon ang mas dako kaysa sending. No? Inana na siya. And that usually happens when you have a lightly loaded transmission line or a transmission line na open circuit, meaning walay load. Zero load ba? Wala ni magkonektahan og load ng transmission line. So Ferranti effect happens. Okay? Mudako na nun imong VR kaysa imong VS. Okay? But this is usually kana observe, no, in lines nga open circuited. Okay? Ano na siya? Sige, malayon ta. Okay. Now, let's go to single phase short transmission lines. So single phase ata. Okay? So all of our quantities, no, are single or single phase. Wala tay square root of 3 bakit under eh. So for short transmission lines, remember that resistance and inductance only are taken into account. Okay? And for a short transmission line, the way we represent it is that we concentrate, no, or we lump our distributed parameters into one group, no, or one impedance. That's why capital Z, capital R, and capital X inyo makita dira. Basta mo tanan mo, sir, ganun dili capital ang J, patay tani ron, no? J is a or an imaginary operator, no? R plus JX. Okay. So, to continue, una mo niya akong mga kawan. Okay. So, to continue, we have this transmission line, no? By KVL, pak, sabi tabo. So, pwede ka inani na equation, pwede pa ito balihon, negative VS plus I times R plus JXL plus VR equals 0. No? Multiply ra kag negative, origya po ng storya. Okay? So, by this equation, no? Sir, duha man ang imong voltage, sir. Unsa man ang atong pangitaon ana? So actually, itong pangitaon ana is the receiving end voltage. Ito, no. The sending end voltage. Okay? So, sir, ganong sending end voltage man, sir? Because the information that is presented to us for a transmission line will only include 1, the length of the transmission line, 2, the frequency of the transmission line, 3 is pila ka phases, single or 3 phase. 4 is the transmission line parameters, no? R, L, C, no? Or G if na, and the receiving end voltage. Nga naman, because kana good ato ang you remember your machines classes, no? unsa ihatag pirmi kasagaran sa libro or sa problem? Terminal voltage, no? So, ang kanang terminal voltage, that's actually the rated, no? Usually, ang rated na siya na voltage sa imong machine. So, for a transmission line, no, ihatag na ang ratings sa imuha along with the other parameters. So, that's why, no, ato ang missing na value is the sending end voltage. Receiving end voltage, pwede mo ta moingon, or makadungog na gani mo an 11 kilovolts transmission line, automatic na siya. Voltage at the receiving end na siya. Because that's the rated voltage for that transmission line. Okay? So I hope nakuha na sa tanan. Okay, let's continue. No? If we rearrange this, we get this equation. No, rearrange this equation from above, we get this one. Now, for short transmission lines, unsa man ni siya? This is just series RLC. From the word series, sa series dapat same current. Balik-balik yun na from high school, from grade 10 or grade 9, basic circuits. Series gani mong circuit, same ra gyud na in town og current. Okay? So if we have the same current, we can then also say na the current at the sending end is also equal to the receiving end. Okay? Because that's series, no? What time mabuhat ana series man na. Series ang representation for a short transmission line. Okay? So, pwede na to, no, simplify si R plus JXL as an impedance, no, let's say Z sub SE, no, ang bahala, no, if you want strictly good imong butang, no, series impedance gini Z sub SE, ana. Or if we have phasor notation, no, then what we're given to us is okay, correction di ay, sorry, nay correction. Katong akong giingon na sending end power factor. Naa gyud na siya value, no? But it's very close, no? The angle is very close to 0. Okay? Or, no? Kung dili man gani close to 0, naa siya, let's say, difference of 5 degrees, 7 degrees, 3 degrees. Okay? Power factor angle ha, not the power factor na itself. Okay? So, in phasor notation, di ba, ato man ang butngan og angles. So, when we solve, no, for the voltage at the sending end, please do not forget to put the angle of your voltage at the receiving end. So, sir, ano sa voltage at receiving end, sir? Because voltage at the receiving end is taken as the reference. 0 na siya. So, actually, kung mag-calculate mo, no, to save space, pwede rin ka mag-VR. VR na. Dili na ka mag-VR angle 0. Pwede rin na siya. However, please take note, no, you have a power factor for the current. Okay? So please remember that, no, naatay power factor sa current. Sir, na power factor sa impedance? Wala. Okay? Impedance is sa tawag gani, it's an independent, no, na parameter. Okay? So impedance, no, di ka magbutang dira in town ha o power factor. Okay, the only inclusions of power factors kay IR and VR, no, and VS as well, no, kay ini ka solve mo ning VR angle 0 plus IR times Z. Ang goal sana is magnitude ug angle man sa imong VS. So please, no, remember that. Okay, right, continue ta. Okay. So if we consider one phase only, di ba single phase pa to gani ha? If we consider it as a 3-phase na pod, no, we represent the transmission line by 1 phase ra pod. Di ba? Balik-balik na ko ingon, no, kung sa inyong ubang maestro. 3-phase gani, atong calculation is per phase. Same with transmission line, our analysis should be in per phase. Okay? So the equations we use in the analysis of the single phase na lines, no, can be used, no, in the per phase calculations. Okay? However, no, please take note, kining VS per phase, VR per phase, IR per phase, ZR per phase, or Z per phase is sometimes it's not intuitive for from the problem. Dili nimo siya maklaro ba if per phase ba ni siya or dili. So if no given ka an 11 kilovolts three-phase transmission line, so lisod pod moingon ka nga ang imong 11 kilovolts ang per phase. No, it's not, no. Actually, that's the three-phase transmission line voltage rating. Okay? So kato imong 11 kilovolts, sa imong buhaton, imong i-divide og square root of 3. Okay? Oh, by the way, sir, unsay representation sa three-phase dire? Is it Y or delta? So for transmission line ha, it's always Y. Okay, unless otherwise stated nga delta, but it's always Y gyud, no? Y delta, Y connection na ang imong transmission line. So for a transmission line, because it's in a Y it's a Y na representation, meaning the voltage line to line is not the same as the voltage per phase. Diba? Ang voltage line to line is equal to square root of 3 times voltage per phase. So to solve for the voltage per phase, that's line to line over square root of 3. Katong gihatag nga 11 kilovolts, line to siya, unless otherwise stated nga per phase. Okay? So if we interpret no these equations sa katong simple na phasor forms, mao ni ato ang makuha. Please take note for three-phase transmission lines, our voltage, no, or our sending end voltage, the result of our calculation will always be in per phase. So meaning, let's say naakay 10,500 kilovolts for your sending end voltage. No? So that's either line to line, no? But ang gawas ana after calculation gani sa imong kini equation per phase gid na. So let's say 5,000 volts per phase ana. Okay? Please take note no of the operations you're using. Ang gawas ani is a per phase value. Okay. So now let's have an example no to exercise no what we learned. A single phase overhead transmission line delivers 1,100 kilowatts at 33 kilovolts at 0.8 power factor lagging. The total resistance and inductive resistance or reactance of the line are 10 and 15 ohms respectively. Determine the sending end voltage, the sending end power factor, and the transmission efficiency. Okay. Question. Unsa man ang ato ang 1,100 kilowatts? Power at sending or power at receiving?
Receiving.
Receiving. Okay? Receiving na siya. Though, medyo murag ma-confuse mo. Sir, gi-deliver man, ganun receiving man. But that is the receiving end power. Okay? 33 kilovolts, is it receiving or sending? Sama na siya. Receiving or sending? Remember ha, naingon ko katong rating sa transmission line. That's
Receiving.
yes.
Receiving.
That's receiving end voltage. Okay? And 0.8 power factor lagging is the receiving end power factor. No? Kung of course, intuitively mabaw-an gyud mo nga receiving na tanan kay ang gipangayo sending man, di ba? But I want you no to exercise understanding the problem. Which one is receiving? Which one is sending? Of course, 10 ohms is our resistance, no? The series resistance, whereas the 15 ohms is our series inductive reactance. Okay? So meaning our series impedance is just 10 plus J15. So solution. So una natong kwaon, we need to have the current, no? To apply KVL. Katong formula na to, no? Nga Vs equals VR plus IR times Z or I times Z. Okay, since current is the same across the short transmission line, so that's IR equals PR all over VR times cosine theta R or the power factor at the receiving end. So, sir, asa ka nagikan nga formula? Uy, gikan na gyud na siya sa formula nga power is equal to voltage times current times power factor. Mao ra na gikan na formula. Okay? So, sir, wala lagi na square root of 3 because this is a single phase. The problem, this is a single phase line or transmission line. Okay? So, after solving for I, we get 41.67 amperes lagging. If we include, no, the angle, sa to angle ani? Is it positive or negative?
Negative, sir, kay lagi.
Negative.
Negative because it's lagging, right? So, unsa man tong angle? Negative what?
36, sir.
6.87, sir, negative.
87.
Yes. So the angle is negative 36.87. Maglibog ang uban, sir, asa nagikan? The negative 36.87 is just the arc cosine of 0.8. Di na ta magbalik-balik ani nga concept because circuits 2, no? Sukad pa na pag second year. Okay, kung di mo kabaw mo solve sa power factor angle agoy, tay kita aning subject ka. Okay. So this is the current, no? This is IS and this is also IR. Okay, or the current, no, in totality sa short transmission line. Ito na ang box. So atong sending end voltage na di ay pwede na tayo gamit ani na formula. Okay? Compute ta sa value 33,000 angle 0 plus 41.67 angle of negative 36.87 times the series impedance, we get this one. Okay. Sir, unsa ato ang sending end power factor, sir? Naalagay na angle ang imuhang sending end voltage. Yes, na siya angle per me because from this pa lang, no, by mathematical operation ana, you would expect nga naa gyud na angle kay ano man complex numbers man eh. Diba? Complex number ng 41.67. 10.J15 complex number as well, no? So to get the sending end power factor, let us take note of these two quantities. First is the alpha. At sa ganitong alpha ani 0.42. This is
42.
the alpha, di ba? So, how do we get the sending end power factor? The sending end power factor is just the saman. Okay? So, katong akong gingon ganihang close to zero nga angle, no? Sorry, I stand correct. Angle, that is alpha, not power factor angle itself. Sorry. Please catch that in your head. No? So, ato ang sending end power factor that's denoted by phi s. That's alpha plus the absolute value of your receiving end voltage. Okay? Actually, di na siya absolute value in a sense, no? Sige, pangutan ta mo, asa na to i-graph si 0.42 degrees? Quadrant 1, quadrant 1 or quadrant 4?
1, sir. Quadrant 1.
Quadrant 1, di ba?
One.
Positive man na, quadrant 1, dagto. Next, asa na to i-graph si negative 36.87 degrees?
Sa 4, sir.
Quadrant
4.
Quadrant 4, no? Ana, pa diri. Ana na siya. So, nasa gamay nga angle diri, nakita ko nga angle diri, to get the total angle, ano yung buhaton? You just add, di ba? So, that's why that's 0.42 plus 36.87 degrees. So, to get the power factor angle, that's 37.29. Cosine of that is 0.7956 lagging. Okay? So, meaning, the power factor performance of your sending end voltage or sending end is 0.7956 lagging. Okay? So, ang phasor, no, ang phasor nga representation ani nga problem, ani ni siya. Okay? First nimong i-graph is the voltage at the receiving end kana VR. Dire to dire, point A. 0 to A is VR. Sunod nimong i-graph ang imuhang saman IR ug IZ. Sir, unsa pag-graph sa IR? Real part sa current times real part sa impedance. O na imuhang IR. Okay? Sunod nimong i-graph real part real part sa current times the imaginary part sa imuhang impedance which is XL. Ana. Okay? So when you draw I times Z, kini na padung dito. Okay? So this is actually a sa ni? Sa nga triangle. Toko,
Right.
right triangle. Okay? So this is a right triangle. Okay, so turn mo makuha si sunod kay imong i-draw ang sending end voltage, no? So kung unsa to gihatag nga current sa imo, not current, unsa to gihatag nga angle nga alpha sa imuhang kini nga calculation when you solve for VS, mao na ang imuhang opening from the zero and then incline mo ana by that angle, draw din ka no sa imong VS. Sir, nganong ang VR sir na sa zero? Because the VR is always taken as the reference. Okay? And then I, no, ana. Sorry. So sir, yun sa na pag-draw ang I. Di ba naatay negative 36.87? Tumato siya. 36.87. Negative 36.87. Okay? So we won't kanang look into that so much no kay medyo hassle ang kanang phasor diagram. Okay, next. Transmission efficiency. How about for transmission efficiency? Sa ganito formula? Very basic
Receiving
formula sa
over
transmission
Yes.
efficiency. Yes, PR over PS
Yes.
Yes.
times 100%. Okay? So, imong PS is the absolute value, no? Absolute value sa VS times IS times cosine theta S. Or simply just take the magnitude of the voltage, magnitude of the current times their power factor, no? And then mo na imong PS. Dili ka mag-complex nga VS, dili ka mag-complex nga IS. Okay? So remember that no for PS. So by that, no? Unsa tong PR? Sige to PR? 1,100 kilowatts. No? So 1,100 kilowatts. Please take note ha kay basin ang inyong isuwat ra 11,000 ra. No? Ay, wait. Basin ako sa iyo ba balik ta. Pila dit voltage? 1,100 kilowatts. 1,000. Ay, nasubraan na siguro ni. Basta nasubraan na og 0. Okay. So this is 1,100 kilowatts all over. This is our voltage at the sending end times the current, no? 41.67. That's the current. And then times the power factor at the sending end. Sir, asa tayong power factor sending end? Bago pa na nato gisolve ganiha. Okay? Mao na siya. Times 100%. Therefore, your transmission efficiency is 98.44%. Okay? So, gets ra ba? Gets ra tanan? Actually,
Sir.
from other classes, I know, from other sections, so kaingon jud sila mas ginahan sila ani nga part sa power system. Kaya tungod di na sila mag-solve og GMD ug GMR, which is very confusing. I'm not sure no if you agree. Do you agree? Do you agree nga mas
Yes, sir.
kapoy ang GMD ug GMR?
Yes, sir.
Diba? So
Kapoy,
mas kapoy
sir.
ang GMD ug GMR. Okay. So for short, medium, and long, medyo lisod si long, no? Because the formula is very confusing. But I will teach you techniques, no, to kanang memorize, no? Or not really memorize, no, but there's a technique para dili ka nay trick ba to know what is the ABCD parameters. Okay? And from the day sections last sem, I handled their EEIPC 425. I think that's 427 nasa inyo. And that's comprehensive course for generation, transmission, distribution. Itudluan sila sa ilang power system. I was not their power system na maestro. Itudluan sila sa ilang power system o medyo tedious na calculation with medium and long transmission line. Tedious kayo ilang solve, no? Pag abot nila sa akong IPC, sa ako ang Compre 4, dito na sila nakakuha nga. Sa yun raman di ay, ang ABCD parameters raman di ato ang tanawon. So, inana ba nga, kanang the difference, no, with how you teach something na that's very hard is, ma-differentiate ra gyud siya, no? Depende sa tao. Okay, so, by that, I want na, even though kalimot na mo sa pag-solve sa GMD, sa GMR, inductance, capacitance, ma-instill gyapon sa inyong mind ba nga, kung transmission line na kita nga formulation or calculation, we'll always take note of the ABCD parameters. But di na ako i-introduce ABCD parameters sa short, no? Ato na siya sa next meeting sa medium transmission lines. Okay? So, ana siya. Next question or next problem. No? Let's have problem number 2. Nag-una na po ng box. No? So, for problem number 2, this is a three-phase system. Three-phase system, receiving end na power 5,000 kilowatts, receiving end voltage 22 kilovolts, receiving end power factor 0.8, power factor lagging, resistance and reactance 4 and 6. So we will determine percentage regulation and transmission efficiency. So how do we get percentage regulation gani? VS
Minus VR.
minus VR all over
Over
VR.
VR.
Okay? Para di malimot, in minus out all over out. Unsa may in, unsa may out. Inyo na problema. Okay? VS minus VR all over VR. Times 100%. Okay. How do we get VS? Of course, we have to use naman the formula that we just discussed, right? So I will show 2 lines here. I hope you're not overwhelmed. Taran, there. No? Okay, mo na ni akong giingon. Your receiving end voltage should be expressed as in per phase. That's why naana siya divided by square root of 3. Because this 22 kilovolts is a line-to-line quantity. Okay? Next is the power. Diri kini dapita. This is actually a shortcut, no? Normally, depende no kung sa imong learning curve, no? Kung kamao ka nga lahos na nimo kaon ang imong I, di na ka mag-solve another another part of the paper. I equals P mo na. Pwede na siya nimo ilahos sa calcu, and this actually is a really good strategy, especially for those na quizzer, no nga dili na ka mag-solve for I, lahos na ka calcu VR all over square root of 3 plus para kuha ng I load, power at load divided by square root of 3 times voltage line to line, VR is line to line ha, times cosine theta r, no, that is 0.8. Angle lang din nimo negative kay laging man angle arc cos 0.8. Okay. Ano na lang. I think I have a calculator here. What din ako nagamit so far. Let's see if I can show you the calculator. There. I will swap my screen to another screen. Wait, ano lang, kanina lang si kuan. Tatanan ang kuan. Klaro siguro na eh. Sige. So, unsa ni siya sa calcio, sir? Okay. Unsa atong VR? VR na to 22 kilovolts, no? Divided by square root of 3. Pwede na to anggulan og 0. Ginanta man maniguro. Angle, oops. Oh, sorry. Dapat ay naka-complex. Balik. Take 2. 22 kilovolts divided by square root of 3. Angle, 0. Plus. So, i-enclose og parenthesis. No? What is P load? What is the receiving end? Power. 5,000 kilowatts. Divided by square root of 3. No? Times. Sir, unsa ni nga voltage? VR. Atong VR ibutan diri ha kay line to line. Please take note, line to line na siya. 22 kilovolts times 0.8. Okay. Sir, unsaon ang angle? Oh, easy peasy. Angle, negative, arc cosine. 0.8. Enclose in parenthesis. Ay pa na ha, basahin nyo na ng equals dayon kay nakuan mo, na excite mo. Times, dapat ay impedance, no? So may R na to, 4, XL is 6. By the way, this is JXL ha. 4 plus JXL or 6I equals na yun. Gawas ani is rectangular form. Okay? So, I want you to show the sending end voltage in phasor form. So, atong sound ganito patay, nakamagamit ang calcio.
Shift, sir, then ka ng
Sa to
Shift, then complex.
No, sir.
shift 2, 3. Ana. Okay, there. No? So, 138.22.64805. No? Angle 1.639. Very similar, no? Very close with this. Okay? So, ana na siya. Balik tabi. Observe na ninyo maayo. Hindi. Saan to? Inalimot ko. Pinim siguro. Tanawa ninyo maayo gyud ang structure sa kuan. Kanang lahos-lahos. Pero, sir, dili man jud maglibog man jud ko sir oy. Okay ra gyud na ano, wala problema. Solve ba daan ang ay, wa koy problema ana. Okay? Kaya siya kay para ra sa katong mga ginahan, maglahos-lahos. Pero kung maglahos-lahos ganita dapat ka mauta unsa atong ipangbutang ha. Okay, unsa atong power, unsa atong current, unsa atong unsa atong power, unsa atong voltage, unsa atong power factor. Okay, ug unsa atong i-angle. Okay, siya. Basically, this is VR per phase plus the current per phase. Kana siyang expression enclosed in the parentheses. And then, 4 plus 6i is just the Z per phase. Okay? So, ana na siya. Sir, naay line to line nga impedance. Walay line to line nga impedance ha. Per phase na tanan impedance nga ihatag. Okay? Sige. So, na tayo VS. So much for that. Let's continue to voltage regulation. No? So, to get voltage regulation, nakabutang diri, it can either be in phase or line quantities. No? Okay, question class. Kining VS nako is per phase pa ni. What if mangayo ko og line-to-line sending end voltage. What do you do, gani? You just
Times 3.
times 3. So,
Time-
kung line-to-line,
Square root
do
of
not
three.
include na. Yes, you multiply by, not not times 3, no? But square root of 3.
Square
Okay.
root of 3.
So, when you are solving for the line-to-line sending end voltage, i-drop na lang ang angle, no? I don't need the angle, okay? I just need the sending end line-to-line voltage nga magnitude. So 13822.65 times square root of 3. That's your line-to-line sending end voltage. Okay? Because this is your per phase pa man nga sending end voltage. Okay. So, ang atong gisolve man kay per phase man, ara man tay per phase, no? So atong gamiton sa VR dapat per phase pod. Okay? Dili na to kalimtan gyud. Please lang, diri man gud uban. Ang uban daghan jud kay masayop ani. Makalimot sila og per phase. Tapos nilang gigamit sa VS per phase. Or ilang gigamit sa VS line to line, ilang gigamit sa VR per phase. So, wrong na, di ba? So please take note of the quantities you are using. Okay? So our voltage regulation is then 8.825. Please correct me if I'm wrong ha, kay basin na ako'y mga kanang arithmetic errors with solving this. Okay? Sige. Let's have the next question. So, efficiency, I believe it's efficiency. Transmission efficiency. No? Solving for I. Okay, di ba? Naa na ta ato. Kaya to? Ay katong naa sa kuan ba? Naa sa ay katong nasa to ang shortcut. Not shortcut, but matik-matik. Di ba mao man ni? No, mao man to ang current kanay na siya, a part. Kini complex ani, no? Kung gibutan dire, magnitude ra. Okay? So to solve for transmission efficiency, we first get the PS and the PR, di ba? Or we need the PS and the PR. But I will give you another way to solve this one, and this is in terms of the losses. Okay? Ganong nagkuha pa ka sa I, sir? Para asa na? Because we will account for the three-phase copper losses. Okay. Percent efficiency, remember, that's PR over PS. PR nimo kay P load, no? The load or the power at the load, the power at the terminal side, no? The power at the receiving side or N. Okay? So, remember, PS, di ba, ang sending end power, kung balik ta sa inyong machines class, ang generated power is not always equal to the rated power. Why? Because ang generated power mo agim siya losses. No? After losses, mao na imuhang rated power. Okay? So, PS can be the sum of your losses plus your PR. Okay? Base maglibog mo, sir, asa mo PR? Nasisige yung PR. Your PR is the load, ha? Please remember that. Okay? So, P load plus 3I squared R. Why 3I squared R? Because this is a three-phase line. Sir, nganong dili square root of 3? Because you're not multiply. Dili man, wala man tay gitawag nga per phase o line to line nga power. Ay natay per phase power, but man tay gingon nga line to line power. Wala inana, no? Ang ato ay total power. So for total copper losses, that's 3I squared R. Okay? So kini diri nga clause or kini diri nga part sa imong fraction, this is simply just PS, no? If you solve PS, you can do that, no? Wala ko problema if you solve PS. I just want you to be careful of the quantities and then you compare if it gives you the same value, 93.93. Sige, you do that daw. You use PS. Ang PS is, I'll give you, kinay. Ang PS na to is just VS times IS times cosine of the sending and power factor voltage. Or basically, PS is equal to... Okay, suwat ha. Wala ba tiagi? PS. Since three-phase man so this is square root of 3 times VS. This is line to line ha, line to line nga VS times IS. O IS, series man So same na sa I. Then cosine of theta S. Na. Sige. I want you to kanang practice, no? I-check ninyo if 93.93 or close ba to that value ang imuhang efficiency. Sige daw. Amo daw, anak. I'll give you 5 minutes. Easy ra na.
Pila ganitong answer, sir?
93.93% ang efficiency.
93.90 ako, sir.
Okay. Nakuha ra ba ang 93.93? Sigog tabi. Naka-mute man day ko. Nakuha ra ang 93.93? Okay, show me a thumbs up on your cameras if nakuha ninyo. Okay. Okay, I can see thumbs ups. Bantay ang uban hang thumbs up ra nya. Wadi ka baw. Bantay ta mo. Keep ani na to next week ba? Hilig ra ba kay kog surprise ra ba? Sige. Okay. So regardless if you don't get 93.93 exactly, no? As long as it's very close, we can have that. Okay? Pero sir, what if sir kung nakuha is 91 point something or 90 point something? Then you have to review, no? Your quantities, no? Among numbers. Okay, regardless of either 4 decimal places or second decimal place ka nag round off, no? Duol jud kay na siya dapat supposedly. No? Pero if you get 90 and then the answer is 93.93, then you may want to review
Sir,
some
excuse me, sir.
things. Yes.
Kanang VA, sir, ba kay mo nang line voltage, sir, sa sending?
Yes. Balik ko na ko ha. Line to line voltage na if magkuha ta sa ato ang sending end and receiving end power. Okay? Okay, so I think we're done. Yeah, so I think we're done for this topic. Supposedly naata to yung medium kay gipa-advance ta mo pero ala kay kapoy pa. It's a Sunday and I want you to enjoy the rest of the Sunday, the rest of the day rather. Okay, so please study, no? Kay before we do medium transmission line, I will give you a quiz on short transmission line. One problem. So kung marong pag mo sa short transmission line, agoy, kabaw na ka sa imuhang faith sa power system. So yun na kayo ang short transmission line. Mao ni pinakasayon nga topic sa power system. Sa kinsa pa yung pangutanon. No? Marong pag ka ani, naa gani mga dili kakuha tungod kay not really because siguro I'm okay with minor nga sayop, no, problema